Okay, just did. Is that better?
That's better.
All right. Again, I want to thank everybody. I know how valuable your time is, and what we're hoping to do through this series is see if this type of thing works well for us remotely, and then we can pick different topics even throughout the coming year and be able to talk and to brief. What I wanted to do today, though, was to share with you a tool that I use quite frequently, and it's called the multiple regression. And I could go into a lot of mathematical analysis. I love math, and that's where my doctorate is at and everything. But what I'd rather do is show you the value of the tool and how it works and some practical applications, and then some little tricks that will help you as you try to go through the volumes of data we as IBMers put together. I'm always amazed when we do deep dives and we bring in all this data. It's like a series of U-Haul trucks pull up outside, and all this data is unloaded, and we end up piling it on our desks, and then we scratch our heads and think, what do we do with this? How do I draw an analogy? How do I take this data and make it meaningful that I can act on? We go to straight line graphs, or we put it together and nothing happens or no changes take place. And, you know, if I do the right things, I should be able to forecast, you know, if I do X, Y will happen. So how do I do that? How can I tell my account management team that if we do these things, excuse me, this is what will happen and this is approximately when they'll see the results? So all of these kinds of analysis we're going to be showing throughout this week, but it all hinges on multiple regression and really understanding what it is, what you look for, and the dangers behind it. But all the tools we're going to show you this week doesn't really replace the human brain. And one of the things that I have to ask myself after I do a data analysis or a deep dive is I always sit back and I look and I say, does what I'm seeing here really make sense? Because a computer can't make sense of the data. It just adjusts it for you. It analyzes it. But it's really the human brain that has to sit back and say, does this make logical sense? And if it doesn't, then perhaps we've used the wrong tool, or perhaps we're looking at the data in the wrong way. And I love the statement down below that says, you know, remember to err is human, but to really screw up takes a computer, and that's really right. So what I would like to do today then is to talk to you a little bit about multiple regression. To do so, I need you to pull up or to put a couple of add-ins into your Excel capability or your Excel spreadsheets. Hopefully everybody on this call has 2007 or above. I must declare a little ignorance here in that I just loaded 2007 about 2 weeks ago, and I'm still getting used to it. It's quite a difference from 2003 that I've used since I was a little boy, it seems like. So as far as 2007, if you pull up the file that was sent to you, your file should look something like this. This is the data file that we're going to be playing with and doing different multiple regression modeling on. For those that are on the NAV account, you'll recognize this is a DBM survey output, but it could be anything, and I'll go to that in a minute. So this is the spreadsheet, and if you'll go to the Start button up at the top, click on
Harry,
it.
are you sharing on the meeting?
I thought I was. Am I not sharing?
I'm not seeing anything.
Yeah, you are. Whoever's speaking, can you please just ping me directly? It's Matt Godfrey, please. Go ahead, Harry.
Okay. Hopefully everybody can see this. If you go up on the Office button and click on it, you'll see Excel options right there. Then you just click on Excel options. In your drop-down window, you'll see add-ins. You click on that. And what you want to make sure is active is your Analyst Tool Pack and your Analyst Tool Pack Visual Basic. If they're not active, these two will be down here. Okay, all you have to do to activate them if they're down in this area is click on them and click the OK button, and then your computer will go ahead and add them in. It will take a minute or two to add them in. The reason that we want these two in is Excel 2007 has a built-in regression modeling software already in it. There's a number of regression software that you can get out on the web. IBM is encouraging us to use, of course, the software that they approved as part of our image. So what I'm going to be showing today, rather than using the real fancy stuff on the web, is we're going to be playing with the one that is embedded in your 2007 tool. So everybody that has 2007 has access to this tool by using your add-ins. Okay, so that would be the first thing you do. Now, I'll be sending out minutes for this. This is also recorded so you can play it later. So, again, what you're going to do is when you call this up, if your Analyst Tool Pack and your Analyst Tool Pack Visual Basic are sitting down in here in the inactive application add-ins, just click on them and go down to, let's see, I think, let me just try this. Okay, there they are. So let me go back to that. So what you do, again, is add-ins. You highlight the ones you want, or you can just go right down here that says Manage Excel Add-ins. Click Go. So back to the spreadsheet that was sent out in the invite. When you call that up, you go up here to the Office button and click on that. You go and you select Excel Options, which is in mine the second tab from the left on the pull down. That brings you to the Excel Option drop-in window. Down the list of options, there's an item called Add-ins. You select it, and that takes you to a group of add-in options for your Excel 2007. You're going to look for two options called Analyst Tool Pack and Analyst Tool Pack Visual Basic. If they're in the active application add-ins, they're already there. You don't have to do anything. If they're down here in the inactive application add-ins, then what you're going to want to do is go down to the bottom, make sure it's on Manage Excel Add-ins, and click OK, or click Go. Then you'll just come to this add-in table, put a check mark for Analyst Tool Pack and Analyst Tool Pack Visual Basic, click OK, and then follow the instructions from there. It'll take you 30 seconds to add those in. And once you do that, you will find that you have several different Analyst Tool Packs that are here. You do not need to go to the web and install something that's not authorized to IBM. Okay? All right. So now we have this spreadsheet that we're going to take a look at. Now this spreadsheet can represent a number of things. It just happens to be a download from the DBM survey tool that's used by NAB. But it could be anything at all. It could be a download from CSSR where you have the overall and then you have a bunch of different questions and their scorings. It could be a group of employee QTMs where you have a QTM score and all the different things that you're looking for in a QTM, and each line representing a different agent. It could be anything at all where you have a great deal of data and they're separate records, and you want to draw some conclusion, you want to see if there's a pattern, a trend, anything that will give you a hint or a predictor. So, for example, what multiple regression is going to give you is it's going to end up giving you a formula. And you remember in algebra when you used to be plotting lines and you had X and Y values and you'd plug in different variables and each of those variables would give you a plot. and that plot you could draw a line between lines, and it would be a predictor. So if different variables happened, you would know what the output was going to be. That's all multiple regression is going to give you. It's going to give you the most accurate analysis it can and an equation to explain your data. And I'll show you that in a minute and how you get that. So this is the data that we're going to look at. It has an overall score. Now this overall score I'm going to use as what we call a dependent variable. Okay, this is something that I really want to see if there's trends to help me predict the overall survey score. All these other columns, B through Q, can't get them all highlighted here. Those are what we call independent variables. These, I'm hoping, will define what the overall survey score is. Okay, so at the end here, what I'm hoping will happen when we run this, it'll say in order to predict what your survey score is, it will be your overall handling score that you get from your survey times a certain percentage, your all aspect score. So it's just an equation that I'm hoping will define what my surveys tell me goes into computing the overall survey score. So that's what I'm hoping to see through all of this. And I want to know what pieces of data here I should really be paying attention to, what pieces of data really don't tell me anything or don't relate to how the customer rates the survey. And again, we're just going to look at survey data here, but this could be any data at all. If you want to figure out from your QTM forms what elements in your QTM form are really a predictor in my agent quality, you could do that. You could do ASA, you could look at, okay, if I want to predict what's driving my ASA or my average handling time, here are all the individual components that make up that. You can list those for all your employees, and you can say, what is it in my department that we're having the greatest difficulty? What would impact me the greatest as far as my average handling time? So it really depends what you want to look at and the amount of data that you want to have. Okay. All right, so with that, then we're going to run a multiple regression model on this and find out how these relationships work. Now, the way that you do that is you want to go to Data, the Data tab, up on the top of 2007, and then you go on mine, it's the ribbon on the far right. It's called Data Analysis. If I click on that, it's going to give me a bunch of different statistical analysis tests, and what I'm going to be looking for is regression. It's right down here. And I'm going to click on OK. And it's going to pop up an analysis sheet. Now, don't get all excited about this. What we already know is that part of our analysis is we've got labels on the top. And regression doesn't work well with text. It works with numbers. So I'm going to go ahead and identify the fact that it's got labels on it. And now I want to take my Y input range right here. And the Y input range is the variable that I'm going to be using as my dependent variable. So that's my overall CSAT right here. Okay. And the way that you do this is you put in $A, which now identifies this entire column, and it's going to start at $1. Now, keep in mind I've told it that it's a label, so look for the first one as a label. If there's no label, I'd uncheck that, and then I would be where my first data point starts. Then it ends at $A. And if I go to the bottom real quick here, it will tell me how deep this is. 292. $292. Okay, so now I've defined my dependent variable. Now I'm going to go this way and get all my independent variables. Now you need to understand that the maximum amount of independent variables in your 2007 spreadsheet is 16, which is a lot larger than some of the models you can get on the web. So you can have up to 16 independent variables that you're trying to relate to overall CSAT. Okay, so in this case, it's going to be $B, $1. Again, I've got a label. And in this case, I'm going to go to the bottom of the last column. So it's $Q, $292. Okay, so now I've identified the entire spreadsheet here. Now, as far as my output goes, I could, if I want to see my output on this spreadsheet, I could give it a range and tell it put the data from this this cell over. I always like to put mine on a new worksheet. Okay, so let me see, residuals, not going to worry about that. And then I just click OK. I'm going to expand these columns, and we'll go through what this is telling me. All right. So what it's saying is we had a total of 292 observations, which is true because it threw out your data titles for you. Your multiple R and your R squared are extremely important. This tells you how many of your data points will fit within your predicted model, and how well your model fits or will be able to predict the value of CSAT. So in this case, the R squared is the most important one right there. And so what it's telling me is that 93% of the data points, or 93% or 83% of the surveys we looked at will fit the model. That's pretty accurate. That's not bad at all. This also tells an element of accuracy. I don't want to really go into that. So either one of those is okay. So we've got a fairly accurate model here between 83 and 91% accuracy. So that's pretty darn good. Your ANOVA test I'll explain in a minute. Your coefficients are nothing more. Here are all of your independent variables and how they relate to your overall CSAT. This is your coefficients. Sometimes we call those sensitivities. So these are your coefficients. You don't worry about your intercept right now. We'll look at that in a minute. So what this is, if you want to look at these as percents, that's okay. You can do that. So if you want to look at this percent, so we're saying the one independent variable is, let's see, 52, almost 53% of the time. This is your greatest predictor. Your negative ones, we'll get to those in a minute and why they're negative. There's knowledge at about 4%. Jargon, in other words, is the agent able to understand all the buzz terms that are being reported in, is about 5%. There's ASA, that's about 8, 6. So you can just go right on down and say, okay, there's 14% for language. And these here could be negative for a couple of reasons. They could be what we call there may be some multicore linearness in them, which means they're really not by themselves a predictor of CSAT. So what I do is I normally eliminate those. But the real thing you want to take a look at is this column right here. It's called the p-value. And this tells you whether or not the results you're looking at happen by chance or whether there is a high amount of significance in the number that you're looking at. And the rule of thumb on a p-value is if it's less than 0.05, then it's considered significant. Okay? The smaller the number, the more significant it is. If it's at or larger than 0.05, then the greater chance it is that it just kind of randomly happened. There's no real significance, something that you can nail down that says, okay, my results I can highly depend on this occurring over and over again. So you got to really be careful in your p-values because sometimes if you're looking at just the coefficients, it can be very misleading. So, for example, if we were to take knowledge, that line right there, we say, okay, well, 4%, if we worked on knowledge, it would, help 4% of our CSAT. If you take knowledge over here and you look at the p-value on this, it's 0.6. It's much larger than 0.05. which means it's not, even though your coefficient is fairly large, it's not a good predictor. It's not something I would want to focus a lot of time on, because the significance of that element doing much to change your overall CSAT scores in this case, in this sample, is very, very low. On the other hand, if I look at overall handling, that's 52%, and I come over to the p-value, look how small that p-value is. It's 0.3 to the negative 23rd, so you got to put like 22 zeros in front of the 2 and put a decimal in front of it. So this is extremely, extremely small p-value, which means this is a very, very high predictable trigger for that CSAT. Okay, so you go right on down the list, and if you just highlight those, that's one. Where's another one that's low? That's a low one. What is that? That's ASA. There's another low one. That's language. So these are your high predictors. Those are the ones you want to pay attention to. Now
Harry, this is Troy. Question for you. So if I were to sort on these various elements that came out in priority order to quickly identify what you're kind of visually seeing, what's the most important element to look at first?
I would look. The first thing I look at is the coefficients. I want to see how big the coefficient is. If it's a big coefficient, I look at that, pick off that this is making up a majority of my percentage, and then I come over here. The second thing I look at is my p-value.
So coefficient higher, look at higher coefficients, and then look at the lowest p-value.
That's correct.
And the combination of those should give you the things that are contributing most to what you're looking at.
Exactly right.
Okay. Thanks, Harry.
That's exactly right. Right. And the other thing I'd look in conjunction with that is I'd look at the 2 at the top here, your multiple and your R-squared. That really tells me how reliable your model is. If it's down in the 40 or 30%, then your overall model isn't going to hold water regardless what these coefficients tell you down here.
And in that case, Harry, when you were to look at that multiple R-square, and if it was a 40 range, would that be an indicator to me that I need to look at or hypothesize that there are different data elements I need to put into my desired outcome or my starting spot to find what's really driving it?
Yeah, it could be that. I also look at the number of observations that you're looking at. It could be that you don't have enough.
Okay.
And that you need to add a few more observations. The other thing that will drive that number down is if your data correlation is very similar, like if you're looking at surveys with a whole ton of 10s in them in every element, and there's just a few surveys that have variation there, you'll find that kind of makes your regression modeling do interesting things.
Got it.
So it's, again, looking at the data and say, does this data I'm feeding the model, does it really make sense? Is there something screwy with the data itself?
Got it. Thank you, Harry.
So what we're going to do is take a look at this overall handling and see if we can't really, I mean, this coefficient is really high. It's telling me that regardless of what else I do, that almost 53% of this single contributor to CSAT is really what's driving it. And all this other stuff's important, but so I'm taking a look at this, I'm thinking overall handling, that's kind of general. What is that telling me? What is overall handling? And the first question I would ask myself are, could any of these really be sub-contributors to overall handling? In other words, what would happen if I made overall handling a dependent variable and used all of these as independent variables to define overall handling? Because when I think of handling, well, that takes kind of into account AHA, that's kind of handling, whether I do it with urgency, what my handling time is, what my language is, professionalism, that all kind of goes into overall handling. What if that is nothing more than what if overall handling is nothing more than a subcomponent? And so what I'm going to do now is I'm going to say, okay, well, let's I'm going to copy this so I don't lose it. Let's take this totally out. Okay, so now overall handling I'm going to make is my dependent variable. I'm going to see if there's a relationship with these to overall handling. So now I just come right back up, data analysis, regression. It's already there, so A hasn't changed. It now is overall handling. That'll be fine. The only thing that's changed now is there's no Q column. There's a P. So I just have to make this endpoint to P. So once you get this set up, man, you can just zip away and do all kinds of fancy things really quick with that. I'm going to go ahead and put it to another spreadsheet. Click OK. Okay, so now I've just done a real quick regression analysis on overall handling, and let's see what we find. Okay, well, here's professionalism then. Now that's 24% of overall handling, very low p-value. So now I know, okay, well, now I got a predictor of overall handling. That's part of overall handling. What else could I say? Well, let's take a look at jargon. That's 16%. It's got a low p-value. So the biggest predictor so far is professionalism. The jargon is right there. Let's try ASA. Oh, ASA is negative. What about urgency? Is negative. Here's handling time. Oh, too big of a p-value, so that's not really a predictor of handling. And I can go down each one of these. There's language, 15%. Oh, it does have a p-value. So now I'm starting to get into some sub-analysis here, and what I'm finding is that original 52% that we attributed to overall handling, really some of these can group very nicely underneath that. So that's how you can use multiple regression really quickly to carve through a lot of data and to continually go down. The other thing I'd look at up here is what does this model look like? Between 73 and 85%. That's not too bad at all. The significance factor is really your model. Now, it works a little different than your p-value. You're looking here for your f-value. You want it probably greater in this case than 4. I'd have to go to the f table, and I'm not going to do that. I just know, because I've done this so much, I'm looking for something between a lot greater than 4 or 5, and it's 49, so I know that that's going to be okay. And a very, very low significant value, which is good because it's the same thing as your p-value. This is your overall model. This tells you whether or not your model occurred by accident or whether it's a predictive model. So I'm in really good shape here. So again, that's how I can carve it even smaller. So the other thing now I can do, I can say, well, what happens if we take out some of these negative values and rerun the model itself? So we've got all aspects. So what I'm going to do is find that spreadsheet. And I'm going to copy it again and start taking out all aspects. We'll remove that one. What was the other one here? I should have labeled these. Where'd it go?
Hey, Harry, Leslie.
Huh? Yeah.
And I'm sorry if I missed it. Where did the data come from that's on the spreadsheet that has the different numbers and headers here with regards to overall handling, jargon, and so on? The one that was pink has a pink.
Yeah. That actually came from a customer survey, a DBM survey for NAB.
Okay.
And the only reason I chose that is because it has a lot of questions it's asking. I mean, it asks about 12 different questions, and as you know, our CSSR, we ask between 4 and 5 normally.
Okay.
But, you know, the nice thing about using the model here rather than some of the ones that come from the web is when you think of CSSR, you've got other elements there as well. You've got resolver scores. If you go far enough to the right on the CSSR extraction, you've got end-to-end scores. You know, so you could be packing all of those in now to a regression model and taking a look at it, so it not only takes a look at your survey score as far as a help desk, but now you're bringing in some of the other data from your resolver teams and your end-to-end as well, and see what impact that has on your CSAT score. So, you know, sometimes we're really quick to say, well, the resolvers are impacting us. Well, now we can tell that by using this regression model, and you've got 16 elements you can put in there, so you can really start to do some nifty stuff.
Okay. Okay, thanks.
That's all I was showing there.
Okay.
Okay, so somebody help me remember this. So we've got all aspects we're going to take out. We're going to take out contact preference, ASA, urgency. Going to take out that. Those two. I think that's enough. We'll run that and see if that does anything to our model. Let me check one more. Resolution was another one, and confidence was another one. All right. So go right back up here to data analysis again, regression. Now we're going to stop it at column J. Okay. Okay, so knowledge still isn't showing. So now we've cut and diced this like 3 different ways, and knowledge is not coming through as something that the customer is saying in this case is an element that can drive satisfaction. So knowing that I've been to a couple of focus groups or heard customer complaints or heard the account management say that there's complaints about knowledge, all of a sudden I'm starting to think, no, this data isn't making sense unless the customer's definition of knowledge is totally different than what I'm thinking knowledge is, or I'm thinking the account team thinks knowledge. So I've got a team running off training in Lotus Notes. They're retraining on all of the different aspects of Word. Maybe the customer's definition of knowledge is a little bit different. So then I come down here and take a look at jargon and keep taking a look at this thing is growing. And all the runs we've had, jargon seems to be the biggest thing. Maybe jargon and knowledge, and I start to make that in my mind. Remember that first slide I put up? Don't let the data get in front of your common sense. Maybe when we're talking about knowledge, or I'm hearing the escalations about knowledge, maybe it's more the analysts aren't understanding the jargon, or they can't relate with the core application names, and they're struggling recognizing that. So maybe it's not resolution knowledge, it's more of a recognition knowledge. And so the light starts to go on here because I've cut and diced this so many times, and knowledge keeps coming out as something that isn't that important. So that's the value of cutting and slicing using multiple regression. It allows you to dig to levels that perhaps start to better define just general comments that you start hearing from account teams or general comments that you hear from others. So that's where, in this particular case, we had to take the detour and said, whoa, let's take a look at jargon instead of necessarily knowledge. And when the team started focusing on the jargon, all of a sudden, and the common core knowledge of the agents, all of a sudden the CSAT started to pop up a little bit. So again, that's just another way to look at it. But you see that by erasing all the negatives, now we're getting some interesting percents or interesting coefficients here, and going over to the p-values, you know, again, there's just a couple of them that are low. That one is low. That one is low. So it goes back to professionalism now. It's jumped up, and jargon has jumped up. So what have we learned? Well, we've learned that your big hitters now are for your CSAT. We go back to the very first chart. We looked at overall and overall handling, and we made the determination that, where'd it go? There it is. Overall handling was 52%. Professionalism here ended up being a negative. There was no relationship of professionalism to overall CSAT. Professionalism came in when we looked at it in relation to overall handling, which is kind of interesting. Knowledge didn't register very big here. Jargon registered as not so big in its direct relationship to CSAT, but we found out later that jargon is a driver of overall handling, which is a driver of CSAT. Okay. Hopefully this starts to make sense, and you can see some other applications that you can use on multiple regression. Now your ANOVA test, I said I would come back to that. ANOVA helps you to understand how your data is distributed across a line or a data point. If I was to have, what's the best way to explain this? You have a distribution of data, and data points can be all over everywhere. So you begin to worry about your outliers. How do my outlier points, how are they affecting my overall model? You know, are there so many outliers that I can't really depend on the overall model? ANOVA starts to zero in on those for you. It tells you whether or not the data you've looked at and those outliers are having a great impact, you know, on your data. So that's where the significant F comes in. Again, it's like a p-value. You want to keep it really, really low. The lower it is, the more reliable you can say, okay, those outliers are not having an effect on the data that I'm looking at. In this case, and all the cases we looked at, those outliers, I really don't need to be worrying about those. I don't need to be tweaking my data and trying to throw out the high and the low. It's saying that those outliers are not a contributive factor or impacting the significance of my data structure or what I'm trying to draw my conclusions from. Okay, so that's all well and good. The other thing that we didn't really talk about are these standard errors, and it's for each of the coefficients. This tells you basically your plus or minus percent, if you want to look at it like that. So, for example, we talked about overall handling time right here was 53% contributed factor in looking at CFAT or your CSAT. That's, if you want to look at it, it's 53% plus or minus 0.0482, so that could be plus or minus 5%. So this 52 could be off as much as 5% either direction. Okay, we said that these negatives didn't really come into play. What I sometimes do is I'll add in my standard error and see if that negative turns positive. In this case, that's not going to happen there. It won't happen here. So I pretty well know that these two are not playing as a direct relationship to CSAT. It may have an indirect relationship, but it's not direct. It's nothing that I want to go right out and build a lot of corrective actions against. Okay. So before I go on, Matt, are there any questions that people have on the regression modeling itself?
Harry, this is Joanne. If your ANOVA value is not acceptable, how do you decide what value of outliers to remove?
Well, what I would do, if you get a significance value that's not very low, what it's telling you is you have a number of outliers that are just not contributing. What I would do is then I would do a scatter plot, and I'd take a look at your scatter plot and then just visually say, oh my gosh, you know, I've got way too many, and therefore my database itself is really undesirable. I don't do personally a lot of tweaking with outliers. If my significance value is really low, I just say that the data is too spread.
Okay.
The second I start throwing out, stuff, you get yourself into a sticky wicket, and you don't want to do that.
Okay.
Okay. The other thing that you'll find is on occasion, if I go back to the spreadsheet, you'll end up with a ton of independent variables, but not many surveys, like 23 surveys, and you're cutting across, 10 or 11 independent variables, and you go to run your regression model and you get some really screwy results. Or your model itself blows up, it won't run. Normally what you want to do is you want to make sure you have at least twice to four times is actually pretty good. 4 times the number of surveys as you have independent variables. So in this case I've got 16. So 16 times 4, that would really be the minimum number that I would want to really run with. But be very careful if your sample size is really, really small and you're trying to run an analysis on that and make some very big decisions based on a very small sample size. Again, the computer can't come back and tell you, hey, dummy, go out and get some more, data, but you just have to know what to watch for. You really have to be careful there. And normally your R and your R squared values will tell you real quickly if your sample size was too small. But I have occasionally put in a very small sample size on person and got some very high R values, which just says that the data that I happened to give it were highly correlated with each other. But I don't think I would want to make any significant business decisions off of the sample size I had in there. All right, so just be careful of that. Also be on the lookout, as I mentioned before, for sample sizes where the data you're actually feeding it is very similar, like lots of 10s or lots of 5s, and very few variation from that. I mean, very, very consistent data. In that case, I think you already have the trends. You can visually see the trends, and running a regression model isn't really going to tell you anything. Where regression comes in handling is where you look at the data and you say, your eyes just say, whoa, I just don't see a lot of correlation here. The other thing that I would do, that I do, is your independent variables cannot contain zeros. They cannot contain empty or character values. Your regression model will blow up. It's got to have values greater than 1. And so if I have any rows or columns that have blank variables in it or zeros, I normally delete them. I don't even include them in the run. And then I check, of course, and make sure that I've got the accuracy there. It's very tempting sometimes when you have a survey score and the overall score is 5, and then you take a look at, and 5 is the best, and you take a look at all the different questions being asked, and it goes 5, 5, 4, 5, blank, 5. It's very tempting to just say, well, it's probably a 5 and fill in a value. Filling in that value on your own can grossly change the model. So you're much better off just deleting that entire row or that variable and just going from there. If you have enough observations or enough columns, deleting that 1 or 2 or how many you have to delete isn't going to hurt you at all. It isn't going to hurt the analysis. The other thing that you want to make sure is in your Excel spreadsheet itself that you don't have any blank columns. That's why when I deleted them, I closed in. So the model itself, the software itself that's embedded in your 2007 is looking for side-by-side columns. So if all of a sudden I would empty this column out and try to run it, it would blow up because it's expecting values down this column. So you're better off deleting it rather than leaving a blank column. In fact, you have to. So that's a rule of thumb there as well.
So Harry, it's Matt. Let me just remind the team that by default you're all on mute, but if you do have a question for Harry, by all means press *6 to unmute your line and pose your question to Harry, and then when you're done just remute yourself by pressing *6 again.
Yeah, you can't mute me, Matt. This is Tori.
I know, I feel ready.
Harry, question for
you. Yeah.
When I look at the data set, I notice we don't have any, row labels. Is it just important that the data for each element is correlated by some factor, whether that be by an individual call, by date of performance? I mean, how are these data points correlated? I guess it all comes off of a survey in this case, right?
Yeah, each row, that's a good point. Each row in this case on this data is an individual survey. Now, if I was going to run this on agents, and let's say I had 36 agents underneath me, then each row would be a different agent's data. Now, I could have multiple data for the same agent. So for another, I could put all of my agents' data in here for an entire year if I wanted to.
Got it. I just would make sure that the corresponding data that is represented in the columns are all associated with one agent on one line, for example.
That is correct.
Got it. Thanks, Harry.
That is correct. And And then there's a time frame here. I mean, I've taken out any reference of any time frame. So you could run one of these a week, you could run it for a day, you could run it for a month, but all the data needs to correlate with the time frame that you're roping this in. If I said for a year, then all this data would be every survey that I received on this account for an entire year. So just keep that in mind when you're running it, the period of time. And does that make sense? Do you want to rope your analysis into 90 days? Do you want to rope it into what happened last week or maybe for the past year? It just depends how big of a spread of the study you want.
Hey, Harry, this is Tammy. I'm following along on your screen share, but trying to do the same thing on Excel, and it's giving me errors. So I was wondering if you go back into the regression screen and just show me the values that you put in there.
Okay. This one here?
No, under data analysis.
This one?
Yeah.
Okay. First thing I'll ask you, do you have a tab across the top?
Right.
Okay, then make sure that you have your labels checked.
Mm-hmm.
Then you want to make sure that you identify what is your dependent variable. In other words, what is all of your data going to relate to? And in this case, I'm going to have it all relate to my first row. Okay, and so I'm calling that $A, $1, because it starts right there and it goes down to the bottom, and there's 292 rows. So it would be $A, $292 with a colon in between the two.
Okay.
And then I'm looking at all of my data as my independent variables, we'll call them, and that's the data from row B all the way to row Q. Now, in this case, of course, I was using this for another screen, so I would make sure I had the first one and the last one. So the first column, first cell, which is B1, again, a $B, $1, colon, last column, last cell, and in this case, it would be Q. $Q, this column, last cell, $292. Okay. Now, another thing I did not talk about, the default confidence level is 95%. If you wanted to land a rocket on the moon, you could put in 99% or 98%, but the tolerance that you're going to get out is going to be very interesting. You don't need to do that. Or you can also loosen your confidence level to 90, and which I'll do right now, and see what difference is that going to have on the output of my data. Is that going to bring in more coefficients? Is my model going to be accurate at around 90%? And again, I want it to go to a new spreadsheet.
All right, I've got one more question while you're on that screen.
Yeah.
You mentioned we have zeros in the data. What does that constant is zero do?
There's no way to correlate it. So what I do, like for yes or no surveys where you have 1 or 0, I just add a 1 to the data. So my yeses are now 2s and my no's are now 1s.
Okay, but on the regression setup screen there, the one you're on right now, the checkbox for constant is 0. What is that?
I've never used it. I don't know.
Okay.
You can play with it and try it. I don't know.
Harry, this is Josh. One quick question. Though it's not as common, for accounts that might have like a net promoter type score or something like that, would you recommend that does or does not be included in the multiple regression?
I would not do net promoter in there. We're not calculating, as an account, we're not calculating net promoter correctly necessarily. Net promoter is really not a transactional-based measurement. And so when we accumulate it as a transactional-based measurement, it throws net promoter scoring all out of whack. We just haven't gotten around to doing it right. If you want to do net promoter right, we have to do it the way it's done on Miller Coors, where there's a separate survey that goes out either monthly or quarterly, specifically for Net Promoter. Net Promoter is not a good thing to be doing on a transactional survey. That's a whole different thing. But if you wanted to throw Net Promoter in, you could just add it as a column, as an independent variable.
If it's being used properly.
Yeah.
Okay. Otherwise, it could be analyzed separately, and you could run your multiple regression on all the other questions,
Yes.
within the survey, and do it that way as well.
Mm-hmm.
Okay.
Absolutely. Absolutely. Okay, let's see. So when I ran it before, I got an error because I had my input Y range was a B instead of an A. So let's see if I picked up something better. Okay, is this the error that you're getting?
No, it's telling me that it's non-numeric data, so I may just ping you afterwards.
Okay. I'll have to take a look and see now why I'm getting an error here.
Could it be that there is a dependent variable?
You know what? You're exactly right. Nice catch.
Gold star for 10.
Boy, oh boy, you listened. Man, you should be teaching this class.
Well, mine doesn't work, so I only get half of a gold bar.
Okay. So I ran the confidence level for this one is 90% instead of 95%. And so the way you would say that is that you're 90% confident that the results that are being output by your model are accurate. You have still a low significance value. Your percentages are okay on this. And looks like I'm getting somewhat of the same results I did before. So I really didn't change my results much by going to a lower confidence level percentage. Didn't change my p-values much. Okay. Any other questions?
Hi, Harry. It's Brenna.
Hi.
What does the intercept line mean?
The intercept line is, here's where it would be used. If I wanted to write a formula, then I would go my predictor value Y is going to be equal to, and let's just pick off one of these. It would be my overall handling, whatever the value of my survey comes in for that, times point, what is it, 0.52 plus, and I would just go ahead and list all of these things, just right on down except for my negatives. So I end up with this long formula, and then at the end of that formula, I would say plus my intercept value. In other words, where in the graph does it start? 0.3. That's all that's for. It's my offset in my graph. Right there. So everybody catch what I'm trying to say as far as the formula goes? If I want to write a predictive formula that says if I want to predict what and actually I can put overall CSAT. My overall CSAT will be equal to, for any survey, my overall or my overall handling times this value plus, take another one, my knowledge score times this plus my jargon times this plus my ASA times this plus my urgency times this plus my average handling time times this plus resolution times this plus my language times this plus my intercept. And that will give me a predicted CSAT value. So when we talk about glide paths and things like that, and we want to predict tomorrow what this is going to be, and you say, you know what, if I improve if I improve my score for overall handling, what will it do to my CSAT? Well, I could put a new score for overall handling in there. I can say, rather than averaging a 3, let's say I now average a 1. What is it going to do to my CSAT? So you would plug 1 in there, run your formula, and it would come back and say your overall CSAT will be this. So you can actually start to play what-if games. What if I was able to lower it? Or what if during I lost my train of thought. What if during this little improvement plan I focus on language and I totally eliminate language? What contribution is that going to have? You can throw a lower score into the formula, crank it back out, and see. That's what if everything else stays the same, this is what's going to happen as a result of focusing on language. So that's how you build a glide path, by the way, is by using these.
So it's Joanne again. So could I use the what-if analysis for that?
Yeah. Yep. And if you are using this, by the way, if you use this every week or every month, and you start to plot these every week or every month, guess what we've talked about? That little graph model that now is in Sage that Jeff has built for us is nothing more than plotting these coefficients on a time frame, on some sort of a time frame, either weekly or monthly or however frequently you want to run it. You can plot it and you can start to see how these coefficients are differing. Are they changing month to month? Is what you're doing making a difference? Is something else now rising as the predictor? As I have solved knowledge, has all of a sudden urgency popped up and taken its place? Or as I focused on professionalism, did it impact something else? Or as I focused on knowledge and my agents became more direct, what happened to professionalism? So you can start to see inverse relationships developing as you start plotting the values. And that's all that sensitivity model is. It's just the plotting of your coefficients, which we have titled sensitivities. That's all it is. That's all that model is. And on the early versions of that, we were taking into account the standard error, which was helping eliminating some of the negatives. But we don't worry about that too much anymore because most of these are what we call collinear. In other words, they're very equal in value, and one doesn't affect the model any more than another, and they can be removed. Okay. Any other questions on this? And again, we've looked at it as it relates to CSAT, but these things could be anything you want to look at. Anything where you have a large amount of data, where you got numbers all over the place, and you're trying to say, is there a relationship here? Something that I should be focusing on that I'm missing. Multiple regression is a really quick tool, and you've seen how fast we ran different versions of it. Once you've set it up, you can delete columns. You can play games with it. Games, I hate to say that. You do what-ifs with it. And you can start to really drive some interesting trends that you can focus on. You could do it by agent. You could do it through a group of agents. There's just so many applications for multiple regression. If you wanted to evaluate data by center, if you wanted to say, what are the things that Boulder is seeing or struggling with or needs to focus on that maybe Quebec or Canada or Cairo or India or Noida, doesn't have to. What is it that will help us to be better? You can plot all the elements that you want to look at and run a regression model on it and just, find a trend. Are we, I know Jamie's on the phone, are we doing the right, QTM stuff? Should we be, what is it about our QTMs that is really driving CSAT? Well, maybe I want to put, monthly CSAT for a group of agents as my dependent variable, look at all the elements that we check in QTM scores and see if there's a relationship or trend. So it's just amazing the things that you can find if you let your mind go on this tool. It is really good. Anything else from anybody?
Hey, Dave.
Hello? Oh, okay. trying to think if there's any other gotchas that you would need to know. Again, remember, zeros and blanks, tool will not run. Remember always to define in the model what your dependent variable is. That's the variable that you're trying to relate everything to. Make sure that your data looks and makes sense with what you're seeing there. You want to go for your independent variables. You want to take your very first variable in its very first position or cell and highlight all of that to the very last cell in the last column. Let the regression model know whether or not you have labels. You don't have to have labels. You can take them out. You just need to know that when it gives you a reference, it's going to give you a column reference. So it is kind of nice having the labels in there. Watch your p-values. Again, anything less than 0.05 is considered to be accurate. Now, the closer you are to 0.05, and I sent out a p-value write-up a few weeks ago, it just means that it's kind of marginal, so you want to get way far away from it as you can. So when you start to get 0.0003, those kinds of things, then you know you've got a really significant element. Your coefficients will tell you what elements you really need to be focused on. The bigger the coefficient, the more impact it has on your predictability. So a high coefficient and a low p-value, you should be putting up on a flag and waving it. I mean, that's something that statistically you need to be really paying attention to. Multiple regression is a great way to dispel assumptions. So if you have an account team that, as we mentioned before, says it's knowledge and your regression model isn't showing knowledge as your high thing, then take a real good look at what you're looking at. Maybe there are some subcomponents to knowledge that can answer why knowledge itself isn't registering high. We saw that in jargon on the NAB data that we just went through. So, again, the tool can only do so much. It's just making sense of the data and not giving up and cutting and slicing it in different ways to get that analysis the way that it starts to really make sense and flows.
Hey, Harry.
Go ahead.
Just another question. You mentioned with the coefficients being, high and the p-value being very low. But what if the p-value is low and then you have a negative coefficient? Is that still something worth looking into because of the p-value?
No, it just means that there's a high. Again, a negative coefficient means there's no relationship there.
Okay.
And if you have a negative p or a really low p-value, that's just reinforcing that assumption. It's just telling that there's no relationship, and oh, by the way, this just didn't happen out of chance. This is a firm, high, significant non-relationship, if you want to put it that way.
Okay.
Thank you. You can absolutely tell somebody I'm not going to pay attention to this, and my p-value is so low it says I'd be wasting my time if I did.
Harry, one quick one. In the applications, we have lots of analysis that we try to do. Can you explain how this is, and I don't know if you've already done this, but explain how this is slightly different than like a correlation analysis where this isn't necessarily seeing how two things compare, but how a subset of things, react within, when compared to an overall?
Yeah, again, multiple regression, and I should have identified this up front. If you just have one or two variables, multiple regression is not the way you want to go. If I want to find the relationship with two variables, you don't want to use multiple regression. Multiple regression is when I have more than two variables that I'm relating to another. So in other words, I have a dependent variable, something that I really want to understand what's driving it, and I have more than one element associated with that. Then you would use multiple regression, if that makes sense. So if I had overall and overall handling were the only two on the chart here, I wouldn't be using multiple regression. There's nothing that I could use a normal regression, but not multiple regression. Did I answer Josh, or did I muddy the water more?
No, I think you did. Yeah, I just wanted to make sure that everybody on the call understood how this differs from some of those other tools that you might have to utilize or that you might be asked for, or that we're just kind of familiar with already, and now adding this to the mix. How does it balance with everything?
Yeah, and again, this is more of a deep dive tool, everybody. This is not a tool that you just really use. It's something where you got a potload of data and you know that there's got to be some relationship there, and you don't want to go boil the ocean and say, I got to improve all elements of service. And somebody's saying, well, where's your big hitter? Well, I think it's this, but you're not quite sure, or you run off and you do that one, and it isn't moving the needle. Then you've probably missed something. Then that's a really good time to go back, load a multiple regression model, and saying, okay, what did I miss? What's the relationship here really? What's really driving CSAT, or what's really driving ASA? What is it really across the desk that I should be focused on? That's the power of regression modeling. It'll filter out all the noise. It filters out the outliers, and gets right down to the heart of what you should be focusing on. Anything else from anybody? Okay. I hope this was useful. I hope understanding the tool is a little bit better. So now when you see a study that comes out and they talk about p-values, or they talk about coefficients or significant levels, that there's a little bit of understanding behind what is that telling me, and how did they come up with this information. There are formulas behind all this, but believe me, they're very confusing, much easier to use a tool. I'm always available. Just ping me, and I can help you through or step you through multiple regression, or even setting it up. But Matt, hopefully this was helpful to everybody.
No, this is great, Harry. Thank you very much. And team, what I would suggest you do is, for the next sessions coming up, that maybe you log in, 10 minutes prior to the start time, just to ensure that you can actually connect to the web meeting. And Harry and I will be there. If you have any problems, then again, just ping me, and I'll try to assist in any way that I can. And with that, then we'll close the call and, chat with the majority of you at 1 p.m. Mountain. Thanks, everyone.